Hello, and welcome to The Course. I'm your host today, Lee, and I'm speaking with Professor Jiwoong Park from the Pritzker School of Molecular Engineering. Professor Park is here to talk to us about his career path and how he became a University of Chicago professor. Welcome, Professor Jiwoong Park. It's nice to have you here.
Very nice to talk to you, Lee.
So, Jiwoong, can you give me a general overview of your career path from your undergraduate years in college to becoming a professor at the University of Chicago today?
I originally grew up in Seoul, South Korea. I went to Seoul National University for a bachelor's degree in physics. I did military service for 2 years, which is mandatory in Korea, and then went all the way to Berkeley for a PhD in physics. I think I spent 5 years, but in the middle of my PhD, my advisor moved to Cornell, so I followed him to Cornell. So half was done at Cornell. Then I went to Harvard for independent fellowship for 3 years, then got hired as an assistant professor at Cornell. That was 2006, but this time in chemistry, surprise, surprise. I spent 10 years there, got tenured, and then I moved to University of Chicago 2016, and I'm here happily ever after.
So, Jiwoong, can you explain your research interests to me as if you were explaining them to someone who has no idea what you do?
So I often introduce myself as follows. So I'm trained as a physicist. I teach chemistry. I do research in material science and engineering. So it's intrinsically very interdisciplinary, and my goal, or my research group's goal, is to turn very, very thin material to real circuits. So using that, we make atomically thin circuit and atomically thin actuators and atomically thin light waveguide, etc., etc. So we make thin things.
And what's sort of the goal? Like, what kind of science are you trying to advance?
It is often, well, let me put it this way. So a lot of exciting ideas requires new science and new technology going together. And so what we are trying to aspire is that we look at conventional materials and conventional devices, let's say transistor, and then think about a way to make that in a completely new form. What if we can make transistor that can fly, that can swim, and that we can spread as like pixie dust, or we can roll up into a small roll, very, very tiny, and these things. To be able to do that, it turns out that what is really important is to work on new materials. And our cup of tea in terms of research is that we make extremely, extremely thin materials, only a few atoms thick. When you do that, well, by the way, it's very hard to do. And when you do that, then a lot of impossible things become possible. So that's something that we are working very hard on.
Thank you for that explanation. So I want to bring us back to your childhood, Jiwoong. You grew up in Korea, right?
Yes.
What were you like when you were in middle and high school?
So there was a big transition from middle school to high school because I grew up in a relatively poor part of Seoul. And so education opportunity was not as great. So for example, high schools around my neighborhood was not great. And then I remember one of the teachers in elementary school told me about this special high school for kids who are really interested in science and math. It's called Seoul Science High School. And it was just founded. So I got interested in that school during the middle school, studied hard, took entrance exam, and I got accepted. I enrolled in this special high school. It was wonderful because it was really for kids who are interested in science and engineering and math. There were only about 180 students per class, and we were all working hard, but at the same time having fun. So that was a big transition and to a certain degree, very important step that moved me toward where I am.
So, Jiwoong, did you always know that you wanted to be a professor, or did you have other ambitions when you were in high school?
I'm very boring. I wanted to be a professor when I was in high school. Growing up, I thought that I'm interested in science, so I thought that I would become a scientist. But frankly, I never met a scientist growing up. The closest profession that I can think of that was tangible enough that I can describe was this job called professor. Maybe that's why. And professor has this dual role, as you know. There is research, but there is teaching, and you can make a simple connection with teaching. Yeah, I like my teachers a lot, and they do great job really motivating people and then educating us. So if you can do that, and on top of it, if you can do your own thing, research, then I thought that would be great. So maybe that's why.
Jiwoong, you mentioned teachers just now, but were there any particular people in your life, they could have been teachers, family members, colleagues, friends, who supported you? And how did you deal with any challenges that might have come your way, if you had any?
Oh, wow. How much time do we have about this? So I am so lucky and grateful for the amazing teachers that I had. So I don't know what it is, but every step in my career, there was someone who really gave me good advice and who mentored me greatly. And so from elementary school, I already told you about the teacher who recommended me to go to this high school. And then in middle school, there were all these warm and extremely caring people who were encouraging me to study hard. And then in high school, there were a lot of great teachers who recognized that I was very interested and rather good at math. So they helped me learn some special math skills so that I can compete for International Math Olympiad, where I participated. Then in college, I also met wonderful professors at Seoul National University. Now, after I came to this country, there are 3, 4 people who were really, really influential in helping me to become, to be where I am. The most important person is my thesis advisor, Paul McKeown, who's at Cornell University. He's a faculty member in physics. And I met him now 24 years ago when I first arrived at Berkeley. And ever since, he helped me, taught me, and advised me in numerous ways. And now I can really call him my dear friend. And along with him, I met very close researchers and mentors, such as Hong Park and Philip Kim, who both did research in the same research group, and we interact very regularly, and we really help each other. So there are really a lot of people that I should be thankful for. And I'm sure what I said is not complete.
Well, Jiwoong, are there any challenges that you encountered during your career path? And how did you ever overcome those challenges?
I think the biggest challenge when you do independent research is that the first part, independent. So I remember the biggest difficulty was right after I got my PhD. So I went to Harvard and I got this special independent research fellowship called Roland Junior Fellowship. Amazing opportunity because what happens is that you don't have a boss. You are your own boss and you are given a lab. And so your job is just to fill the empty lab and with your idea and conduct research. So I remember that was really, really hard. So before, just if you imagine a very normal research group, you have your professor, you have postdocs, and you have graduate students, and you have a team. But instead, what you were given is this empty space, and you need to fill that space with your idea and your work and to a certain degree your dream. And you need to do a high quality research. And that transition, I remember, was rather difficult because that was the first time there was really no one who's going to tell you what to do. And so that transition, I remember, was quite tough. Now, in hindsight, that was a great period of growth as a result, but nonetheless, I remember it was hard.
Was there anything that you learned through that growth process?
Yes. So one thing that I found very useful was this, and I remember this story from listening to Jon Stewart, the comedian. This is my favorite anecdote that I like to share. When Jon Stewart started his show, Daily Show, and I think he went to Letterman and to ask for his advice about what he should do. And Letterman's advice at the end was that if you are going to fail, fail doing what you like to do. So I thought that for a researcher, that was a very good advice. Of course, Letterman did not give that advice to me, but I heard that later on. So when I was struggling to figure out things to do for my new independent research group, what I was constantly thinking about is this, what is the big problem that I can really work on? And another thing is that if it's such a big problem, it'll take a long time to work on it and contribute to. And often you do not know everything, or you do not have the right skills to address these questions. If you analyze all of this, then what I found is that you really need to figure out new skills that you need to develop, or new knowledge that you need to develop, or new relations that you need to develop. So I think that was my thought process that I started with at the time. And I thought that was a very good skill set that I've learned. Figure out big problem and try to think about what we need to work on to get there, instead of just delving into something that you can work on and you can get some short-term results right away. So you always have a choice. But I thought that I would rather work on something that can lead to a big growth with a bit more uncertainty, rather than something that will give you quick result with much higher certainty. I hope this makes sense.
Well, to that point, how and when did you realize that molecular engineering was something that you wanted to dedicate time and research to?
So we first, molecular engineering is a wonderful name, and the Pritzker School of Molecular Engineering, I think, is a aptly chosen name. And because a lot of important problems of the modern society should be worked on at this scale. Now, my involvement in this direction is very, how can I say, gradual. And my original training was really low temperature physics. Just to give you an idea, I measure things at extremely low temperature, very cold. And so that is a very particular regime where physics is studied. But at the same time, gradually what I realize is that before you do all these careful measurement, I wanted to make sure that I get to control the material that I study. And that often involves making structures using something called nanofabrication facility. It's a kind of modern day machine shop that makes all these semiconductor chips, or molecule-based objects such as polymers. And so while I think about exciting things to study, I was leaning more and more toward the question related to how do I make it and to what end. And I think that was a very important transition, rather gradual, but my interest in the impact, if you succeed, then what's going to happen? And I think that constant questioning of related to impact, I think that influences you.
And so, Jiwoong, building off your last answer, what is it that you aspire to do now?
I'm so glad that you added a word now, because my interest tends to get influenced by what we see in my research group. If you asked me that question 5 years ago, my main interest was to make integrated circuits, such as semiconductor circuits that's only a few atoms thick. It turns out that in the past 5-6 years, we worked on that and we made quite tangible progress. And if you ask me now, then I can say that, yep, with the proper investments and scaling up, we should be able to do it. Now, currently, what I am very interested in is this question about how to turn molecules into something that is not like molecule, but very, very useful. What do I mean by that? What I mean by that is that when you think about transistor, you think about silicon, which is a single crystalline material that's made out of dust, pretty much. Can you do the same thing with molecules, starting from them? For example, so if you can do it, then we should be able to make it in a bigger scale and then with many more different functions. And it might be able to be compatible with interfacing with biological cells. So this is something that I am getting more and more drawn to, and hopefully we can make a great contribution to.
So, Jiwoong, can you share with me some of the fun parts of your job and also some of the not so fun parts of your job?
there are a lot of fun things that I did not expect to experience as a faculty member. There are several. For example, being friends with a bunch of Nobel Prize winners. That's pretty interesting because I never expected to be friends with all these amazing scholars. And these are nice people and fun people at the same time. And another thing is really when people think about scientists, people think about white gowns and then being stuck in the lab, late night work. These are the things people imagine, but it's not quite true. And the people, when we gather, we have a lot of fun together. The thing is that a lot of friends that I hang out with, especially when I go to conferences or meetings, I met them when I was in graduate school over 20 years ago and through other conferences or meetings. And I follow their career, we meet each other, and then whenever we met, we are old friends. So just making old friends and then seeing them regularly, that has been just really unexpected and fun part. The same goes to all these students that I taught. And so let me see. I just last week, two of my newest graduates defended the thesis, and now I have 13 graduate students and maybe 15, 16 postdoctoral researcher who went to academia and research industry, and being able to stay in touch with them. I think this is the most fun part of my job. There was another question, right?
Yeah, what are some of the not so fun parts of your job?
Oh, writing reports. So one thing that I did not know is that a lot of my time is spent on writing research proposal to raise money to pay for my students and also all the chemicals that we are going to use in the lab. But that's okay. Still, proposal writing is something that I enjoy because I develop new ideas and study to convince other people. Somehow, report writing has been always a struggle because the nature of work is that our work is that we discover something and then report it, and then it's exciting. But once it's reported, it's not as exciting for some reason. So by the time that you need to write down what you have done in the past year, I just never get too excited to write reports. So that's something that I really do not enjoy. I have to do it. That's something that I don't truly enjoy it.
So, Jiwoong, what advice would you have for someone who is considering entering your field?
So one thing that I would like to encourage people to do is to talk to experts who are in this field to find out what it is like. Now, I think one thing that's very important is this question, whether you enjoy doing this or not. And if I see one reason that makes me get up early in the morning and then check my email in the middle of night to reply and then write something very late is because I really am having fun doing all this research and also teaching new things to my students and share discovery with my other colleagues in Chicago and outside around the world. So I think you should really enjoy this. And now another thing is that, especially for molecular engineering and chemistry and physics, the nature of modern research is such that it's becoming more and more interdisciplinary. What I mean by that is that I think it'll be a good idea to have an open mind about what you are going to do and then pursue that direction, regardless of the conventional label that people will attach to it. And often you find something, exciting. And I think the name Pritzker School of Molecular Engineering is a very useful example because one of the ways to think about the brand of molecular engineering at U Chicago is that we think about engineering department that does not exist, but that is necessary. And so the new thing that we are going to do, I hope people are excited about that. And you would be interested in doing it, and you should be courageous to try new things. And these are a couple things that come to my mind.
And finally, Jiwoong, what is the most gratifying thing about your job?
It's people. It's very simple. So if there is common thing that really made who I am possible, it's really all the people who helped me from my elementary school days. Of course, I should not forget my parents and my wonderful family, my wife and my son. But at the same time, there were all these people who helped me and then who taught me a lot of important things to really mold me as the scientist I am. And sometimes that person starts as a teacher, such as Paul McMillan, and then later he became a really true friend. And there are many people like that. And I should not forget to mention even a program manager, someone like Dr. Harold Weinstock, who I first met in Taiwan, who became a champion for my research and who really became a wonderful mentor. And there are many examples. So the most gratifying thing is all the people who spend time with me and then share ideas and really open their thoughts with me. And that includes all my talented and hardworking graduate students and postdocs who really trusted their time and career with me and trusted my advice for a very, very long time. And I think I'm truly lucky for all of this.
I've been speaking with Professor Jiwoong Park. Professor, thank you for your time. And course takers, if you enjoyed listening to today's interview, please check out the other ones. You can find out more about the University of Chicago through uchicago.edu or the university's campus in Hong Kong through uchicago.hk. Thanks for listening.